could be good for me.
Salam to Sir Fabian and hi to everyone. My name is Nur Fakira from BMMV S1/2 Group 2. Today I would like to present about force and factor of safety analysis from actual structure.
That I won't scratch.
First thing I will introduce about our project. In solid mechanics, the safety factor refers to a numerical value that represent the ratio between the capacity of a structure or component to withstand applied load and the accepted or design load. It is a measure of the safety to the design to ensure structural integrity and prevent failure. Next is stress is defined as the force per unit area of plastic and has unit. Third is the yield strength is the stress a material can withstand without permanent deformation or point at which it will no longer return to its original dimension. For this project is number 1 to draw detailed FBD from actual structure related problem. Second is to develop equilibrium equation from the FBD drawn, and third is to analyze force members from the structure. We have chosen tie arc bridge as our structure, as you can see in figure. This is our actual structure and idealized structure, which is we have force, moment, and we need to calculate all the moment at the structure.
Assalamualaikum and hi, my name is Muhammad Yasir Razim bin Yusri. My metric number B0921100086. I'm going to present a free body diagram of the bridge. The distance of the bridge is 200 meter from point A to B. As we can see, the bridge has one roller support at point A and a feed support at point B. Hence, there are two reaction force at point A, which is horizontal and vertical force. Meanwhile, for the feed support at point B, it only have one horizontal reaction force as it use feed support. After a few research, we can determine that generally the distributed load on the bridge is 5 kN per meter. Next, for the calculation, we will calculate the external forces first by using moment at point A. From there, we can get horizontal reaction force at point B, which is labeled as By. Summation of force on horizontal also calculated to find reaction force at point A or Ay, which is 500 kN. We use method by point to calculate the internal forces of each truss. And at point A, there are two trusses that we must identify the force, which is truss AC and Ka. By using equation of equilibrium, we can determine that FAC is 4198.25 kN and FKA is negative 4168.37 kN. From the value of forces on both trusses, we acknowledge that FAC is in tension and FKA is in compression. Next, at point C, we also use equation of equilibrium, and FCD is 4171.7 kN and FKC is 333.31 kN, and both of them are in tension. For point K, equation of equilibrium is used to find FKJ, which is 4168.37 kN, and the truss is in tension.
My name is Karakma bin Triman. My metric number is B09211038. I will present for the calculation and the factor of safety. For the calculation, we use equation of equilibrium. At point D, force at DJ is equal to 1000 kN. Then the bridge is symmetrical, so the force is equal on both sides. At point E, for the FDE equal FCD, so it equal 4171.7 kN. And at FHE equal to FKC, we get 333.31 kN. For at point H, FHJ equal to FJK, we get 4168.37 kilonewton. And at point B, for FBE equal to FAC, we get 4198.25 kilonewton. And at BH equal to FKA, we get 4168.37 kilonewton. For the factor of safety, we assume the cross-sectional area is 0.16 meter square and the ultimate strength is 40 MPa. For the force, we take at the higher force, which mean force at BE, FBE is equal 4198.25 kilonewton. To find the available load, which mean stress, we use formula force over area, and we get 9.882 times 10 power of 6. The formula factor of safety is we use ultimate time strength over available load, which mean stress, and we get the value of factor of safety is 5.812. Factor of safety is 5.182. Since factor of safety is greater than 1, it means that the structure can be considered safe to use.
Conclusion. In conclusion, by the following the step outline, a comprehensive analysis of the structure has been performed, considering its idealized model, assumption, FBD, EOE, and the mechanical response. This analysis allows for a better understanding of the force acting on the structure and help ensure its safety and functionality within a predicted limits. By analyzing the force, both external and internal acting on the structure, we can understand its mechanical response. This analysis provides insight into how the structure will behave under different loading conditions.